Hi, this is Mike Casey with Home Inspection University, and today we're inspecting the interior of a home, and specifically in this location we've got what looks like a gas fireplace. Now I'm not sure if it's wood burning or not. We're going to have to get in and take a look at it, but just to give you an idea what we're going to go into and look at in depth is down here you can see we have our glass doors and what looks like a factory built fireplace. I can see on both sides we have the intake holes and exhaust holes, because every factory built fireplace is essentially a box inside of a box, and it allows airflow around the box, and that's what keeps it cool, so they can be installed with what's called zero clearance or very minimal clearance to combustibles on the back side. Now this one's set right down on the floor. We do have non-combustible material on the floor, but typically these factory built fireplaces, if that's what this is, may have some different rules than masonry fireplaces for the hearth extension. But we're just going to get down and personal and real close up with this right now and see exactly what we have here. One tip off I do see on the right hand side here of the mantle and the fireplace surround, I see a switch. So that's kind of telling me right now, before we go inside and look at it, that we may have what's called a gas only appliance. But we're going to get right down here and open it up and take a look and see if it works. So come on down inside with me. Okay, we're going to get real close to this fireplace and take a look inside. And I like to spend some time on fireplaces. Essentially, a fireplace is controlling fire inside your house. So it's real critical as home inspectors that we pay attention to them and look at as much as we can inside of a fireplace. So let's go ahead and open this one up. While opening it, I'm checking the glass doors to make sure that they're working properly, sliding nicely. And now I'm looking inside this firebox. I can see we have cosmetic logs, and also right here at the bottom, this little cover plate, that tells me that this is a gas-only appliance. So does the depth of the firebox. Normally your firebox depth is going to be at least 12 to 18 inches if you're going to be able to burn solid fuel. This one's pretty short. There's really only enough room for the cosmetic logs. So I'm going to just pull this off and look inside. We can see our gas valve, and the valve is on, flex connector, the mechanical components, the gas valve itself, and it's a gas-only fireplace. Another tip off many times is they're supposed to leave this little label for you. A lot of times it's chained to the inside. And we'll take a close look at this. But it says, do not remove this label, so don't take it with you. And it also says in big letters, listed vented decorative gas appliance, not a source of heat, not for use with solid fuel, not for use with a thermostat. So they're pretty clear on this. It's a gas only, really cosmetic appliance. It's not a heater, and don't burn wood. And I've seen where my clients have misunderstood. They think it's a fireplace, so I never call this a fireplace. I always call it a gas appliance in my report. And I tell them it's not for solid fuel. So let's take a look at some more components inside. And here's how to really tell whether you have a gas appliance or a wood burning appliance or not, is to look up inside at the flue, which I always like to do anyway. I get on my back and lean in there and have a look and see what there is to see. But you can see here we have a B vent, so we know this is a gas-only appliance. So we're going to go ahead and test this gas appliance. So what I'm going to do is use the normal operator controls, and essentially that's just walk over here or kneel and turn on the switch, and we'll see what happens. So as you saw, we turned on this fireplace, we flicked the switch, and this unit should ignite now. We know we have gas in this house because everything else, this gas is working. So let's take a look and see what happens here. I'm not getting any noise out of it. Looks like no ignition. And looking back in here, I can see it has an electronic igniter. So there's no standing pilot. Matter of fact, that's the the transformer for it. The gas valve is on. The gas valve in the back is on. So the main gas valve is in the on position, and the gas supply valve is on. So that tells me that something's not working. And that's pretty much as far as we're going to go as a home inspector. So now what I'm going to do is write this up in my report as a gas appliance, and it did not respond to normal user controls, and I'm going to recommend an HVAC contractor or a gas appliance contractor to go ahead and see what's wrong with it. Hi, Mike Casey with Home Inspection University, and today we're looking at appliances, and we've got a gas cooktop in this house that we're going to inspect right now. And typically the first thing I want to do is look at the installation, make sure there doesn't look to be anything dangerous. I will take a quick look underneath, make sure there's nothing unusual, and we'll take a closer look under there in a couple of minutes. And I want to make sure that it's working properly. I usually like to make sure it's tight in the countertop, and then operate all the burners. And it's normal to hear that snapping sound, that's the igniter. And many times on different models of these units, you'll see a spark when you're opening up the gas to one burner. You'll see that spark occur at all four burners at the same time. And that's typical because the igniter tube goes to all of them from a single igniter. So that's normal stuff. And then we want to look closely at our installation. And this one has something a little bit unusual on it. We've got a nice brand new granite countertop here. And I didn't notice this at first. And just when I was leaning over, looking at it, I can see that we have, it looks like either the wrong cooktop or someone screwed up with the granite countertop. But there's a pretty big hole back here, right down. Actually, I can stick my hand in it, and we'll show you here in just a minute. And this I did not see from across the room. So, and it could have been easily concealed. So it's important to take a real close look at the install because you never know what you're going to find. So let's take a look at that, and then we'll go underneath and look at the installation. And we can see here on the back of this cooktop that we've got probably 1.5 to 2 inch gap between the countertop and the self-rimming portion of this cooktop. So that's a pretty significant item. I mean, obviously it can be fixed rather easy. It's just going to cost some money. But I certainly wouldn't want to get a phone call about this later on after I did the inspection. So it's important to take a close look. See this here? Unusual defect for sure. But this house has got it. Never know what you're going to find. And now we're looking underneath that gas range. We were just checking with the large gap behind the self-rim on the unit itself. And this is a downdraft exhaust fan unit. So we're going to take a look at the underside of it. I like to identify that there's a gas shutoff and check the gas connection, and also look at the exhaust piping for that downdraft fan that's in this unit. So let's take a look at that. And we can see here this is the housing for the exhaust fan. In the center up here there was an opening for the fan to suck the fumes down, and the fan and blower is right here. And what I in particular like to look at is the exhaust piping itself. And it's supposed to be all hard pipe like this. That's hard piping for exhaust. And someone has inserted here, probably when they put this new cooktop in, and used this flexible metal type of ductwork as the exhaust for the fan. And that's actually improper. The code does say that all kitchen exhaust fan ductwork should be hard metal, and that it should not have any type of configuration that could catch the grease and so on and cause a fire inside. So this section of pipe right here should be replaced. Not a big deal for someone who knows what they're doing. And then generally what I see on a slab on grade home like this one is when it penetrates the slab, there's a good possibility that this is going to be plastic piping, which is okay as long as it's underneath the slab. That is allowed. You can see here they've used some aluminum tape to make the connection, and that's okay. But what does need to get replaced is that flexible material there. Okay, we're still underneath this gas range, and we're looking at the gas connection. And here we have a flexible connector, and that should be not more than 6 feet long. And I always do want to identify where the connector goes and where the shutoff is. Now I'm looking underneath here, and we'll show you a shot here in just a minute. But the flex connector is penetrating a hole that's in the cabinet. Not really supposed to do that, but I see it a lot. I don't think it's a really big deal. I just want to identify that we have a gas turnoff here. So we're going to open up the next cabinet and show it to you and make sure that we've got a proper shutoff. I don't see where the flexible connector is subject to damage. Looks to be in good shape. So on this one, what needs to be done is that exhaust piping needs to be replaced. And then, of course, somebody needs to do something with the hole in the countertop. And here's the shutoff for the cooktop. It's reachable, so I don't think it's a problem getting to it, so it looks to be in good shape with that. Now when we're doing kitchen appliances, typically we're only inspecting the built-in appliances. Most home inspectors don't inspect the refrigerator. Some do, and that's certainly your choice. Now in this home, we have no refrigerator. We have basically just an alcove for the refrigerator. And this one's kind of small, so I would probably make a note for my client to make sure that they measure the opening before looking for a refrigerator. You know, this one is not all that large. I also want to make sure we have a receptacle for the refrigerator. And I can't tell you how many times I've looked at a kitchen refrigerator alcove and there's been no receptacle, or I see this odd hole in the wall, wondering what that is, and then I figure out, oh, it's for an extension cord to get a receptacle or get power to the refrigerator. So it's an easy thing to miss. I've also found it missing oftentimes when I do new construction inspection and there's no drywall up. Take a look at the kitchen. Make sure they remember the receptacle for the refrigerator. You'd be surprised how many times they forget. And then lastly, down here at the bottom, you can see that we have an ice maker hookup for this refrigerator. So this is a little tiny 1/4-inch type of a valve that they would hook a copper or a plastic pipe to have an ice maker. And it's been my practice to not test those. I don't turn them on. I don't fool with that type of valve. Of course, I will make a comment if it looks like it's been leaking or there's been leakage in here, but this one looks pretty clean. Okay, we're inspecting our kitchen appliances, and I tested the garbage disposal, or attempted to. I turned on the switch and nothing happened. So there's no power to the garbage disposal or something going on. So we're going to investigate further and take a look under the sink, which we should be doing anyway because we're looking at plumbing and there's lots of components underneath this kitchen sink for us to inspect. So we're going to take a look inside. And I can see our garbage disposal is unplugged. Now that tells me that there may be something wrong with it, or there could be another reason. So I want to look a little bit closer, and I can see back in here the receptacle, and there's a new dishwasher installed here, and what I can see is the flexible cord for the dishwasher, the plug end on it is too large because it has to plug into the dishwasher side of this receptacle, and it covers the receptacle for the garbage disposal, and that's a switched receptacle, remember, so we have to use that one. And there's no way to plug in our garbage disposal while having the dishwasher plugged in. So I don't think this homeowner is going to want to be plugging and unplugging dishwasher and garbage disposal as they're using this kitchen, so that's definitely a reportable defect. And we'll get a little bit more of a close-up for you on this one. It's a little hard to see in the back, but it's certainly an unusual defect to find. Hi, I'm Mike Casey with Home Inspection University. We're inspecting the interior of a home here in Southern California. And what we're going to do right now is inspect the kitchen receptacles. And we've got the small appliance circuits here for the kitchen countertop. And generally that's going to be GFCI protected, that's ground fault circuit interrupter protected. And that's to protect people to help them not get shocked. So we're going to test these receptacles first. I'm going to look and make sure that they're properly grounded and proper polarity. I'm going to use a little simple circuit tester. These are probably $5 at your hardware store. When you buy these, you want to make sure that you buy at least a half a dozen of them because they will go bad. If you start getting odd readings out of it, before you trust the instrument, go get a new one and check and make sure you're getting the same reading if it seems real odd. I mean, I've seen where it tells me that the grounding conductor is energized, and I can tell you that that's a really rare occurrence, and most likely that would trip a breaker. So if your instrument is telling you things like that, you want to test it and check that your instrument is working properly. So we've got a simple circuit tester, and we're going to look at the GFCI device and the receptacles in this kitchen. I'm also looking at the countertop for any defects that are reportable while I'm doing my inspection of the kitchen. This one we inspected the appliances. That's a different show, and I hope you watch it. And we can see here we have our wall switches, receptacles. I can see the GFCI device for this circuit, or these two, or at least one of them is right here. Now I'm going to test a receptacle over here and make sure it's properly wired. And this one, you can see we have the two amber lights are on. And on this instrument, if you read the label, it'll tell you that those two on is normal wire. Otherwise, this one says correct. Now the GFCI device is over here. We're going to test that. And a lot of these testers will have an internal GFCI tester device, and those are fine if you like to use those. I choose not to. I prefer to use my finger as the GFI test device because that forces me to find it first. Because sometimes these are pretty well hidden, these devices, and if you trip it and then can't find it, you can spend an hour trying to find it. So I'm going to trip it, and this one tested. I heard it pop out, and we can see that the receptacle is de-energized. The next thing I want to do is check the other receptacles in the kitchen here and make sure that they're de-energized as well. So we're going to check the one over here. De-energized, that's good. And we've got one more over here behind the plant. That is also de-energized. So it looks like that GFI serves these receptacles. So I'm going to go ahead and don't forget to reset it. And then I check it again to make sure it's actually working. It's back on again, and it says correct wiring. And I'll check one more, and that looks good. So I think our circuits are good, the GFI is working. Now, generally I will not test these if it looks like there's something plugged into it that I may affect, or in other words, like blow the program on it, so when people come home, everything's going like this at them to reset it. So if there's something plugged in that I'm going to affect, I won't test the GFI, but I'll make sure in my report, I write it down in the report, it appears in the report, and I tell the clients why I didn't test it. We're going to continue on in this kitchen and check our receptacles in the GFCI devices. Now this house happens to have a separate kitchen island. Now an island should have at least one receptacle within 12 inches of the countertop. And we have one here, and it's GFI protected, which it should be because it's in the kitchen and it serves a countertop. And we're going to go ahead and check this one. Now here's our circuit tester. It shows that the wiring is proper. Now I'm going to go ahead and test it. So we should be able to push the test button. Sometimes you have to get your instrument out of the way. Now you can see I'm pushing the test button on this GFCI device, and it is not responding. So that tells me that the device is defective, and this whole unit should be replaced, and I'm going to recommend an electrician be contacted to install a new GFCI component. So that's an unsafe condition because the GFI device is not working. So we've just tested that GFCI device at this kitchen island countertop, and you remember that it wasn't working properly. Now some inspectors like to carry a more unique tool for checking receptacles, and typically I don't carry this around with me all the time on a home inspection. I'll use it often in older homes, often when I think that there might be what we call a bootleg ground, where they've taken 2-pin receptacles and replaced them with 3s, and then just jump the neutral to the grounding terminal and try to fool your little instrument with that as a full ground, which it is not. So I like to use what's called a sure test, and this device will tell me a lot more information about this circuit. And this one also happens to have a GFCI internal test. So we're going to make sure that this unit is defective, like we found before, by plugging in this device. It's got a little pigtail on it that you can use. And we'll plug it right in here. And it lights up. And it's going to tell me what's going on with the circuit. It's done a test. I'm getting green light on hot, ground, and neutral. So that tells me that they're properly connected. We can go ahead and tell what voltage is. We've got 121.9. That would be typical. Most household circuits are going to range between about 115 to 130 or so in voltage. So that would be normal. You can see it just changed to 122, back to 121.9. So that's good. Now we're going to go ahead and test the GFCI. So I'm going to push the button that says GFCI, and it's going to perform a test. It's leaking 7.5 milliamps to the ground right now, and nothing is happening. So our GFCI test is going to fail. We're leaking current and the GFCI is not tripping. So we know for sure this component is bad. So we're going to recommend an electrician be contacted to replace this component. So we're going to go ahead and unplug, and we're done. We're sure that that device is bad. So we're going to move on to the next part. See you there. We're continuing on with our interior inspection in this house, and basically we want to try and look at everything that's visible. Now here in this room, I can see that we have our walls. I'm looking at walls for unusual cracks. I'm looking for water stains, just anything that says to me, come look at me closer, that there may be something wrong. I'm looking at floor coverings. Baseboards in particular I like to look at because if there's evidence of water, it typically will show up at the baseboard as maybe rusted nails or other indicators that there's been moisture here before. Also, sometimes I've seen in tiles like this, if there's a lot of moisture underneath, you can actually see efflorescence, which is that white powder that you see on concrete sometimes, actually coming through the grout joints and sometimes even on the tiles. So take a good look at the floor tiles. These hard surfaces will also tell you if there's any unusual movement underneath, because a lot of times you'll get some cracking right through this hard floor surface that'll telegraph through from the concrete. And then of course in the rooms I always like to check a representative number of the receptacles, so I'll check them on my way around. And also any windows that I can get to, I like to open them up. And of course you have to pull out your window coverings, and be careful when you do this. I've opened these before and they've fallen off, so you want to hold on to things as you're opening them up. And this one we've got some hinges, and we'll pull it open. And I'm going to check the lock on the window and then move the window and make sure that it operates smoothly. I'm also looking for any evidence of moisture around the bottom track of the window. And don't forget to look up at the head of the window up here. That's a good spot to pick up moisture or evidence of water intrusion from the siding. Look at the corners, look at the sill, operate your windows. Make sure you put them back in the position you found them in, and also close your window coverings. Now we're not required to inspect window coverings, but I have found houses where these are loose or they're not properly installed or they're falling off. And usually if it's something that's real obvious like that, I will make a note of it. So we're continuing our interior inspection on this home, and I've been looking at the walls, checking receptacles. We want to look up and check ceilings, and we're going to check another window. And again, we have to open up the window coverings carefully. Now here we have a single hung or vertical sliding window, and we want to unlock it. Now on this one, I can see that the lock is damaged. This one is loose. And over here, the lock mechanism is missing. So I want to be careful with this window. We're going to check it for operation. It seems to be kind of loose to me, but it does stay up. So that's a good thing. We'll go ahead and close it. And I'm probably not going to lock this. Yeah, I think it's too risky. I don't want to break it. So we have a condition here with this window where the locks are not working properly and we have a section missing. But I can still look for evidence of water intrusion around the window. And like I said before, always look in at the head up here. Look for water stains. And then you want to look at your sills, in particular at the corner for any water stains. Down here at your corners. And this one looks pretty clean. So basically we have the condition with the locks that should be reported. Hi, I'm Mike Casey with Home Inspection University. Now today we're going to be inspecting a bathroom. So we're going to test for functional flow with the drainage, functional flow with the water supply. We're going to check operation of the fixtures. We're going to look for evidence of water intrusion in the room. We're going to check the toilet. So we got a lot of things here to look at. This bathroom we have a stall shower, we've got a tub, we've got a double sink over here, and then a small what's called a water closet right over here. So I think where we're going to start is we're going to go in and check the toilet that's in the water closet. So I'll see you in there. So we're in a small water closet, which is normally for a toilet, and that's what we're looking at right now. This one happens to have light fixture, also a fan. So I don't know if you can hear that, but the fan is working. It's actually kind of noisy. So we have a fan in here, that does work. The next thing I want to do is take a look at this toilet. So the first thing that I'll do is break out the flashlight and look around the base and behind it, looking for any evidence of water leakage or anything else that appears to be out of the normal. So I'll check both sides. The next thing I like to do is what we call the toilet dance, is I want to make sure that it's actually fastened down. And I don't like to touch them, so I just kind of move it with my legs like this. And that way I don't have to grab a hold of the bowl and I can make sure that it's tight. Now, be careful when you do that, because if it's really loose, you could actually send this thing moving and start a water leak. So do that gently. Next thing I'll do, pop the lid, look inside, and I'm looking for cracks. Anything unusual with the toilet. The porcelain should not be cracked. Usually if there is a crack, there'll be a buildup of bioorganic growth in the crack, so it'll be pretty clear. And the next thing I'll do is go ahead and give her a flush. Make sure it works. Now you have to watch it. That's the sound we want to hear. That it all went down, and it flushes with what we call gusto. Now some inspectors will flush them twice. I actually like to do that. I'll let it fill up again. Usually I'll grab a little bit of toilet paper if there's any available, toss it in and make sure it takes it down. So close the lid, make sure the tank is tight. That looks good. Some inspectors will look inside. And this one looks pretty normal, nothing unusual, but you want to be careful, because if you drop that lid, they can be pretty expensive to buy, or even find one if it's an unusually older type of color. So that's about it for toilets, and we're going to move on and go ahead and look at the shower now. Now we're going to inspect the shower stall. This one happens to be a separate tub and a shower type of a hookup, and the first thing I want to do is look at the enclosure for the shower. And make sure that everything looks to be in good condition. There's nothing loose. It doesn't look like the door is going to fall off on me when I try to open it. And then I want to get down and look real close at the base. And I'm looking for evidence of water leakage here. This is a pretty common place to find evidence of leakage. And while I'm down here, I'm also looking for a safety glass insignia. Now, it's pretty tough to buy a shower enclosure that's not safety glass, but I still like to look and make sure that it says so right on it. So I don't see them down here. We'll probably find them inside somewhere, but I'm going to keep looking for that as well. And this one's pretty clean. I don't see any evidence of past moisture. Looks to be caulked pretty tightly, so it looks to be in good shape. So we're going to go ahead and go inside and have a look. I like to walk inside the shower first before I turn any water on, because we're going to, of course, check for functional flow. The reason I do this is normally the shower pan is going to be dry, and I'm not going to leave a bunch of footprints and get my feet wet. So I walk inside first. So we're inside the shower now, and we're going to look at the window. I'm going to make sure that it works first, and that does work. Now, keep in mind when you have a window in a shower like this, it's going to get splash water. If I'm standing here taking a shower, water is going to get in here. So it has to get out of this window. And I'm going to be looking close here and also on the outside for any evidence of water intrusion. Because most windows aren't designed to be waterproof from the inside out. Usually it's the other way around. So we'll go ahead and close the window. They also are required to be safety glass. Anytime the bottom edge of the glass is within 5 feet of the shower or tub base, it should be safety glass. And in fact, most of the time they're just safety glass anyway. And this one I can see right here is the safety glass insignia. Now the next thing I'm doing is looking around for anything unusual with the shower enclosure. Now this one, this is kind of a pet peeve of mine, is the low shower head. Now, typically most plumbers will put the shower head arm at about 6'6". This one is definitely lower. It's probably, I don't know, I'm about 6'1", so maybe 2 or 3. And this is a head knocker shower head. And this one could really do a little bit of damage to that bald head. So I'm probably going to comment on this in my report as the shower head was a little bit low and to use caution when using the shower. Now, as far as I know, there's nothing in the code about a minimum height for that, but I can tell you from my days as a plumbing contractor, we always use 6'6". Next thing I'm looking at is over here on the glass. Once again, I want to make sure that we have a safety glass insignia. And this one has it up here, so we can pretty much assume that the entire thing is safety glass. It's really hard to buy non-safety glass these days. Now this shower enclosure is one of the better ones that I've seen, and this enclosure itself in the bottom track has weep holes right here. And this allows any water that gets in between the glass and the frame itself to weep out at the bottom. And I have seen where people have filled these with silicone caulk. These are designed to be open so that the water can get out that gets inside here. So that's a good thing. They should not be caulked shut. So now I've done my inspection from inside the shower stall, and I'm satisfied it's in good shape. We can see from here that the sill for this window is sloped back in towards the shower. That's a good thing. And the enclosure is in good condition. I don't see any evidence of water intrusion anywhere. Nothing loose, no caulking falling off. So now I can run the shower valve itself. So we're going to go ahead and turn it on. And I turn it all the way to hot because I want to make sure we're getting hot water out of the hot side. And you see it took that big shower head a little while to fill up. So when we first turned it on, it looked like the flow was really slow. And don't let that fool you. You got to give it a few minutes. This whole shower head has to fill with water before it starts coming out full stream, because it's one of these big, what they call flood heads. So give it a few minutes, and I'm getting hot water. I'm going to go ahead and turn it back to cold, make sure it actually changes and that we do have cold water here. And the temperature is reducing. The flow looks to be pretty good. So now I'm going to let that stay going like that. I'm going to go ahead and close the door because I like to run the heck out of the shower. I don't just turn it on for 30 seconds and turn it off. I like to go ahead and let it run for a while. So if it's going to leak, hopefully I'm going to be able to see it. And then also while that's running, I'm going to turn on some more fixtures. Now, we should run at least 2 fixtures at the same time. When I have a number of different fixtures in the bathroom, I kind of go a little bit extreme on it. I tend to run everything all at the same time. So we're going to go ahead and do that. I'll show you what we have over here in just a minute. So we're still in our bathroom, and we're going to test our vanities. Now the first thing I do before I turn on any sink faucet, I always want to look underneath first, because you never know what you're going to find. I've actually seen these where they look great, and you open up underneath and there's no trap installed. So I'm glad I didn't turn it on. So first thing we'll do is open up underneath, and this takes a get down on the knees and take a look underneath. Underneath the sink looks to be in pretty good shape. I don't see any evidence of leakage. The drain looks to be in good condition. The stop valves, no evidence of leakage. And by the way, you don't want to touch these. Don't be testing those because they can break off easily. So now I think we're good to go ahead and turn it on. And I want to stay here and watch it while I run some water and make sure it's not leaking. Many times I'll just feel it with my fingers and look for water. This one looks to be dry. I'm going to make sure that we have hot water coming out of the left side faucet on this one. And it looks to be in good shape. Now some inspectors will go even further and they'll pull the drain stopper and fill up the sink and test that as well. Some inspectors will also test an overflow if there is one. We don't have to do that. As a matter of fact, I really wouldn't recommend that. It's pretty rare that the overflow is operated. So we put some water in the sink, drain it out. No evidence of leakage. Nothing on my fingers. So it looks good. This bathroom also has what some people call a spa tub or a soaking tub. Usually spa tub is what I hear it called. It's really just a big bathtub and it doesn't have any jets. Now we've gone in and we've inspected our walls. They look good. This window, I've checked it for operation and I've also made sure that it has the safety glass insignia on it, which it does. Many times I find these windows that are not safety glass And what I'll do is walk around the house and find another window about the same size. And many times by mistake, the safety glass window was installed somewhere else, like in a bedroom, and the wrong window was put in here. So sometimes they can just change the sash to go ahead and get their safety glass. So a couple things on this tub. What I like to do is before we turn it on, is get in, and I'm going to check the drain. And this overflow, I like to shake it, just like that. And if it's loose, that tells me that if too much water is put in this tub, and it's going to go down the overflow, it will leak for sure. So whenever it's loose like this, it needs to be at least tightened up, although they may want to have it checked by a plumbing contractor because sometimes the gasket will be damaged because of that. Next item I'm going to look at is the spout. Make sure it's tight. And then the next thing I'll do is get out of the tub before we turn the water on. Now this tub has a two-handle control valve, and this type of a configuration, it's important that the hot water be controlled from the left-hand side control valve while you're inside the fixture. And that's the interpretation that should be used. Some people say, well, it's on the left if I'm outside. That's not true. It should be for the user who's in the tub should expect hot water from this left control valve. And we're going to go ahead and run this tub and make sure that that's working. Already got hot water there. So that works. Make sure the cold water works. We got cold here. The drain's a little bit slow. I don't know if you can hear that, maybe. But the water in the tub is draining a little bit slowly, so I'll probably recommend that that be checked, or not probably, I will, that be checked as well. Remember, we had the loose overflow cover, drains a little bit slow. It also looks to me like the drain cover is a little bit cockeyed and not working properly. So the last thing I want to do now is my functional flow test for both water supply and drain. So we're going to just go ahead and crank everything on here and make sure it all works. So I'll see you in just a minute. Now we're doing our functional flow test in this bathroom. We've got all the fixtures running. Now keep in mind you're only required to run two concurrently, meaning at the same time. And what I've done in here though, I like to just run everything. You know, let's make it, it's a busy morning, everybody's trying to get ready and all the water's running. So we've got two faucets going, and we can see we've got real good flow here. The tub is running, and that's a big spout. That's taking a lot of water, and we also have the shower going. Now with all these fixtures going, we have plenty of flow to take a shower, take a bath, use the sinks, and probably use the toilet too. So we've got lots of flow here. The drains are draining out. The water is draining out of the drain as fast as it's coming in, which is what I want to see. So we look to be in good shape. The tub's a little bit slow, like we talked about before. I can see that starting to fill up. So that'll be a recommendation to have that checked. But everything else looks to be good. So when I'm done with this and I'm satisfied, I'll go ahead and turn everything off. Once I turn everything off, what I've learned to do is just one last look. I'll take a look underneath the vanities and make sure I don't see any water dripping. One last look. Looks to be in good shape. Now I'm happy. I can go ahead and leave this bathroom and keep moving on with my inside inspection. So I'll see you there. We're continuing our interior inspection on this home, and we're in a little, kind of like a study or a den type of a room. And we can see we've got some glazing that looks over the living room down below. That's kind of cool. It does have a safety glass insignia, which is a good thing. Now, we're testing our receptacles as we go along. Most of the time we're going to carry our little circuit tester with us, and we're going to check these, make sure that they're properly wired. That one's good. Usually I like to do at least a couple in every room. And something else you're going to see a lot is phone hookups. Now here we have a couple of different ones. This is labeled HM for home, probably fax. So we've got a couple of lines for phone here. There also is another one over here. And clients many times will ask you about phone lines, computer wiring. Now all that type of low voltage or signal wiring is going to be excluded from a home inspection. And you need to make it clear in your reports, and if people ask you that that's not part of the inspection, And what they might want to do is have the service supplier, wherever they get their phone service from, check and make sure that everything's operating. And if possible, they could also ask the occupant or the seller, although many times they're already gone. So we don't check phone lines or cable TV, that type of thing, low voltage stuff. While we're doing our interior inspection, you may run across what's called a ceiling fan, and that's what we have here in this house. And generally I like to inspect these because oftentimes I find them pretty much out of balance, or gosh, sometimes they almost look like they're going to take off and hit the ceiling when I turn it on. So be careful. What I first do is find the switch that turns it on. So we've had our light turned on the fan, and then I like to just go ahead and gently pull the chain. Don't pull it too hard because sometimes it'll just yank right off in your hand. You don't want that to happen. Wait for it to get up to speed, listen to it. Sometimes they'll click and bang and make a lot of noise. And keep in mind that these are most of the time in bedrooms. So when you're laying in bed at night and that fan is clicking and making noise, it's going to bug the heck out of you. So you want to make sure that you tell people if there's any unusual sound coming from the fan. Now this one, hardly any vibration at all. Looks to be in good shape. I don't see any movement in the blades. Hardly any vibration at all, even in the chains. This is usually where you can pick it up, as these will start moving around. And usually we have a few speeds. We run high first. This would be medium. This would be low. That would be off. And there's your ceiling fan inspection. Moving on to the next one. During our interior inspection of this house, we're up on the second floor now, and we've come across the laundry room. So we're going to check our laundry hookups, and we'll take a look over here. And first we're going to have the clothes washing machine right here. And this one has what's called a cut-in box or a rough-in box. We have our drain opening here, and that should be cold, and that should be hot water. Now, home inspectors are not required to operate these valves. So I would make that clear in my report that I did not operate them. I will check the receptacle. This one shows correct wiring with my instrument. Now a question I get quite often from inspectors, when you have a clothes washer hookup on the second floor like this, if we look here at the floor, there's no drain and there's no catch pan for the clothes washer in case it overflowed. So second floor clothes washer, my recommendation, and it's not a requirement of plumbing or building codes to have a catch pan under your clothes washer, but I'm going to recommend as an upgrade that they have one installed here. Usually it can be a steel type of a pan with a drain on it that could be run to an outside wall, hopefully if there is one, or a place to get rid of that water. Because on the second floor you could have just a simple towel or something clogging the clothes washer could cause it to overflow. So I'll make note of that, but definitely it is not a requirement, at least now, not in 2014. The rest of the hookups we'll look at here are for the clothes dryer. We have 240 volt available for the clothes dryer, and this one is a 4-pin receptacle. A lot of your older homes are going to be 3-pin. This is a newer style 4-pin. So we've got 2 hots, a neutral, and then we've got the grounding conductor. So there's 4 pins. Most people have a clothes dryer with a 3-pin cord on it. So you may want to tell them they'll probably have to get a new cord installed if they have an electric clothes dryer. This one is much safer though, because it separates the ground and the neutral, which is what we should have throughout the house. We also have fuel gas hookup for the clothes dryer here. It looks like that's probably what they were using before. And this one happens to have a cap on the end of the valve. So someone has capped off the valve, which, that's okay. A lot of times I see them, they're not capped. And then we have our clothes dryer exhaust. Now this one probably goes vertical and goes up through the roof. Now whenever I see clothes dryers, a lot of times they haven't been cleaned in a long time, and this vent pipe should be cleaned regularly. A lot of fires start in clothes washer exhausts, so I'm going to tell my client that they should have this cleaned probably annually, and they'll usually have to pull out the equipment and run the cleaning up through it and then pull out the lint. So it's especially critical when you have a vertical vent like this one that goes through the roof. During my interior inspection, I like to operate all the doors that are possible. I'm looking for a couple of things. First of all, of course, that the door operates and it opens so that people can use it. The other things I'm looking for are things that are out of whack with the door. Sometimes the frame will what we call rack, and that tells me that there may be some conditions that are foundational that we need to look at closer. Other things I'm looking at with doors is sometimes I'll find homes where along one plane of wall, all the doors in that plane of wall tend to swing by themselves a certain direction. And that can actually be an indicator of a pretty big defect where the whole house is tilted. So again, that's really just something that'll tell you to look closer at foundations and that type of thing when you see doors doing weird things. Now this is a double door for a master suite, and we have the secondary leaf here. Usually it's going to have a little type of a lock at the top and sometimes one at the bottom. And then this is the primary leaf here. These get out of whack a lot, so I want to make sure that they're working properly. So we'll close it. And many times on these doors, the secondary leaf fastening devices don't work properly. So if someone's outside, like a little kid, comes and pushes on the door, they're coming in because it pulled out. The lock up here doesn't work correctly, it needs some adjustment. So somebody outside can just kind of push on the door, and if you push it hard enough, it'll pop open. So make sure the secondary leaf lock works properly. It's usually a minor adjustment, and many doors have them down low and up top, but it's very common for these to not be operating properly. Hi, Mike Casey with Home Inspection University. We're in a kitchen today, and we're going to look at inspecting some appliances. Now, many home inspector standards of practice, those published by associations and also those published by states, don't require that you inspect kitchen and built-in appliances. However, many of the associations offer that as an optional type service, and many home inspectors inspect the kitchen appliances along with their inspection as a service to their clients. So we're going to look at inspecting some components. And here in front of me right now, we have a big double oven. Now, any type of an oven, whether it's electric or gas, the first thing that I do is look for any damage. A lot of these are glass, so I'm looking for anything that's broken, anything that's missing, any parts that don't look like they belong here. The next thing I'm going to do is look inside first before I turn anything on. So I want to open it up, look inside. Oftentimes there's bread or other types of storage inside of an oven, so you'll want to look first inside both of them. This one looks clear. I think we're good to go. The next thing I like to do on an oven is make sure it's fastened to the cabinet. I find a lot of these where if you took out a pan and put some pressure on this door, the whole thing will tip forward. So I want to check that, and I'm going to look and make sure that usually there's some screws right here around the perimeter, and make sure that it's snug in the cabinet, because many times they're not. Now I'm satisfied the inside looks good. I'm going to look at the door, both doors, for any damage to the glass. We're going to look at the gasket. If there's any tearing or looseness of the gasket, that's a reportable item. I'd recommend repair. I'm going to look at the elements, make sure there's nothing that looks like it was damaged. Sometimes when they're starting to go, the element itself will actually start to expand and crack. And then in the back we've got a couple of lights, so I'm going to be checking those for a couple of things. First of all, operation, and then second, to make sure the covers are actually installed. And don't forget to look at the upper element. That's going to be your broil element. The lower one is the bake element. And then I do that at both ovens. I'm happy that it's secured to the cabinet. Once I'm satisfied that everything inside is in good condition, I'm going to go ahead and perform a basic function test. Now, I generally do not check to make sure that it actually tells you the temperature that it is in the oven. Most of them are off. Some inspectors will use a thermometer that's approved for inside of an oven to let you know if it matches what it says on the dial. I pretty much just turn it on and make sure that it gets hot and turn it off. It's a fundamental function test, not an accuracy test of the thermometer inside the oven. So we're going to go ahead and turn it on. Upper oven, temperature, that's on bake, so we're going to let that go. And then we want to go lower oven, and it's on bake. Maybe crank it up a little bit. And then I'm going to just let it heat up and make sure that it works. Now, many times what I'll do is close the door about that far, because I want to make sure I'm not going to walk away and leave this oven on. So what I like to do is, while I'm testing it, is I'm going to go ahead and leave the door open a little bit to remind me that it's still working, because I don't want to walk away and then be driving down the street later on today and think, oh darn, I didn't turn off the oven. So this is my key, my visual key to myself, to come back and turn off the oven. And we can see it's preheating right now. I make sure the elements get warm. Sometimes I'll touch it with my hand. You want to be careful about that. So I'll check it in both bake function, that's the lower element, and also broil function. So we'll give it a couple of minutes for the lower element to get warm. We'll turn that off, and then we'll go ahead and turn it on broil, and that'll test the top element. So we'll be back to it in just a second. Okay, we've had the lower element, which is the bake element, on for a bit, and that's definitely hot, so we're going to go ahead and turn them off. Now I want to make sure that the upper element is working as well. Now to do that, we have to hit upper element, or upper oven, custom broil, high, start. It's telling me the door is open, I know. We're going to go to lower oven, we're going to turn that on, to custom broil, start, and they both should be operating. Okay, the broil elements are being tested now. The upper one is hot. I'm checking the lower one. This one is red hot, so we know we're good. So both elements in both ovens are working, so we can go ahead and make sure you turn them off. Hi, Mike with Home Inspection University again. We're going to take a look at inspecting a dishwasher. And the first thing that I like to do with a dishwasher, and you would think maybe open the door, and it's not. I like to look very close down underneath at the floor. And we want to make sure that there's no evidences of previous leakage. If there is, we want to report that. Another thing too is, many times there's a pretty thick floor that can make it difficult to remove the dishwasher when it goes bad, because we know it eventually will, and that might be something that I want to let my client know about. So once I look here, I'm satisfied that there doesn't appear to be any evidence of previous leakage. I might run my hand on the underside of the door and see if there's any moisture. This one is dry. I'm going to go ahead and open it up, because I want to look inside first to see what's in it, because sometimes it's not dishes. And I'm going to look at the door for any deterioration, corrosion, particularly here at the bottom. I also want to make sure that the unit has been fastened to the underside of the cabinet, so we can kind of push down on the door a little bit, not too hard, and make sure the unit doesn't move or tip forward, because that can be a hazard. Now I'm satisfied that the unit's not going to tip forward. I'm going to go ahead and pull out the carriages and look inside. Now obviously I'm making sure that we have dishes in here and not other types of storage, because I'm going to run this unit too. And we have dishes, so it's being used as a dishwasher and not storage for other components. Inside, I'm going to look at the tub itself for any evidence of corrosion. It's pretty normal to see in some models a little bit of water in the bottom of the tub here. That's a typical thing, maybe an inch. Some of them none, it depends. I'm going to make sure that this piece spins down at the bottom, your spray wand, and typically there's one here as well underneath the upper carriage, and I'm going to spin that and make sure it's working, it's not loose, pieces of it falling apart. I'm going to look at the carriages, make sure that they move. Now a lot of times on these carriages the plastic will start to deteriorate and it exposes the steel and it starts to rust. That would be something I would tell my clients about. This all looks to be in great shape. I think this dishwasher is pretty new. So now I'm satisfied with everything inside. I'm going to roll the carriages back in, go ahead and close it up, and we're going to run the unit. Now I like to read the front, and generally what I'm going to do is hit light and tell it to just start. I'm not going to use steam or any of the special functions, and I'm going to run it through a cycle. What I like to do is hear the unit pull in water, swish around a little bit, and then pump out, and then I'll typically hit cancel and drain, so I'm not running it for a couple of hours. Now we're going to look at the components under the kitchen sink that connect to this unit. All right, while that dishwasher is working, we can look at the connections underneath the kitchen sink here. We can see the drain line is here, and it starts coming out of the dishwasher. It comes through a high loop up underneath the kitchen sink and then back down into the garbage disposal connection here, which is a pretty typical connection. I don't see any evidence of leakage. Obviously, I'll note that the cabinet has a little bit of storage in it, which is pretty typical, but I don't see anything that looks like there's past leakage. So now that I've checked this, I'm going to go ahead and push the cancel drain on the dishwasher so I can watch that water pump out here and make sure that there's no leakage. I can hear the water draining. It looks to be in good shape. This hose here should be up a little bit further. It really shouldn't have a trap in it, so it should be a little bit shorter. Not really a big deal, but something that I would recommend be done to help prevent it from clogging. The water supply valve is way in the back here. Looks to be a standard type connection, stainless steel hose. Dishwasher's just about done pumping out. Once it's pumped out and I'm satisfied that it's turned off, we're all set with our dishwasher inspection. Another thing to keep in mind, on some states on the West Coast, there's also required to be a vacuum breaker on the dishwasher drain line, which is going to be typically that little chrome protrusion at the kitchen sink where it goes up through this hose, connects to the vacuum breaker, and then comes back down to the garbage disposal or the waste connection. Mike Casey, Home Inspection University again. We're going to take a look at the garbage disposal now, and before I operate it, I always like to look at it. The same with any appliance. I want to make sure that it looks safe to operate. This is a typical garbage disposal. I'm looking at the connection to the sink and the disposal itself. I don't see any evidence of leakage. This one has a straight connection to the sink drain on the right bowl. These types of T's typically have a baffle inside to help push the waste that comes from the disposal downward. If it didn't have one, you do have the risk of some of the waste coming up in this sink bowl. But this looks to be a standard factory made T with a baffle. The wiring on this one, it looks like non-metallic sheathed cable here, and it shouldn't be exposed to damage like this. There should be some kind of protection here or a flexible cord with a plug-in. What can happen is that cable can be easily damaged and it could cause a shock. So I'd recommend that be corrected. And this one, we're going to try and get a shot of it. There's no cover on the junction box or stress clamp on the cable. Now we're going to go up and look at it from the top side. All right, top side on the garbage disposal. Before I run it, I want to look inside and first make sure that there's nothing stuck inside. And second, look at the condition of the grinder plate and the little flywheels that spin around. So we're going to look down inside with a light. And you can see the top of the unit's pretty rusted. That tells me it's getting older. I would say it's probably nearing the end of its useful life. I don't see anything like a spoon in here that's going to be damaged if I turn it on. The blades look to be okay. Now this is the sink guard. A lot of times these go bad and they can be replaced pretty easily. So we're going to go ahead and turn it on. It actually sounds pretty quiet. And it's really quiet because the little pieces, the cutter pieces that spin around, aren't moving the way that they should. It really should be quite noisy so that those wheels are moving around and chopping up the food that's in there to spit it out into small pieces. So my guess is this disposal probably just kind of beats around pieces of food. It doesn't do a very good job at making it disposable. So I'd say this unit is near the end of its useful life or at the end, and they may want to consider replacement. Hi everybody, one more thing I wanted to add when looking at garbage disposals. On this brand, which we were just looking at in the video, you can see they tend to crack right along the casing here. So make sure you're looking around the front and the back of these for evidence of leakage and cracks. That's typically how they fail. Sometimes the cutter wheels rust up or freeze. This is another mode of failure, and of course the engine can just seize up. So be looking for cracks on this brand.